window, control window up. No. I'm not sure how to has started. Okay, that's good. Oh, okay, Nusafia, you help me to record. Okay, good. Thank you. Okay, so let's continue. What is it? Okay. Okay, so key steps in statistical modeling are as follows. First, we need to formulate the mathematical model. That means we need to find a mathematical or statistical model that can fit our data. So we are fitting model to our data. And then from there, we construct a model prediction. That means we estimate the parameters of the model. And then we need to validate or we need to assess its adequacy and so on. Okay, so many problems in engineering and sciences involve a study or analysis of the relationship between two or more variables. So correlation and regression, linear regression are the most commonly used techniques for investigating the relationship between the variable that is independent and dependent variable. So the correlation analysis is used to identify whether the relationship between the variable exists or not and to quantify the strength and direction of the relationship between the variable. Whereas regression express the relationship in the form of equation. So regression form an equation. Correlation measure the direction, the strength of the relationship. There are two different terms there being used. So I think we have gone through this, isn't it? Betul? Yeah. We talk about correlation coefficient where the value is between -1 and 1. Am I right? We have talked about it last week, yeah?
Yes, Doctor.
Yes. And then we have a correlation coefficient. Yeah. R, when we write small r, yeah, lower r, that means it is for sample. Yeah. Most of the time we use sample. If the symbol is rho, yeah, rho, it is the population correlation coefficient. Okay, so if R closer to 1 or -1, the correlation become between the variable is considered strong positive or strong negative relationship respectively. Okay, so positive correlation indicate that if one variable consistently increases and the other also increase, yeah, so that is a positive correlation. So negative will be opposite, one increase, the other one decreases. Okay, so note that correlation does not imply causation. That is, if two variables have high correlation, it does not mean that one variable causes the other, the value of the other variable to increase. Yeah. Okay, this is an example. Okay, this is actually for R squared. Whenever we square the correlation coefficient, it becomes coefficient of determination. So this has another meaning. Yeah, coefficient. So coefficient of determination, it quantifies the proportion of variation in the dependent variable that has been explained or predicted by the independent variable. Yeah. So it is actually the square of the correlation coefficient. Yeah. If correlation coefficient is it gives the direction and strength of the relationship, whereas R squared will tell us how many the contribution of independent variable towards the dependent variable. Yeah, quantify the proportion of variation. How much variation? Yeah, variation in the dependent variable, which is contributed or which can be predicted by the independent variables. Yeah. Oh, this is too big. I need to make it smaller. Okay. So if you look at this graph, this is actual and so the residual mean the difference between the point on this fitted line, what we call it, fitted line or regression line is residual. The difference between yi minus y hat. Y hat is the predicted. So that is the residual. Okay. Okay, linear regression is used to predict the value of a continuous y based on one or more input. Okay, so we have two types of regression. One is simple. That is whenever we have one continuous dependent variable against one continuous independent variable. So that is a simple linear regression model. And the model that we got is called line of best fit. Okay. Whereas for multiple linear regression, it is a model of y and a continuous variable against the a continuous more than two or more of the independent variable. Yeah. So when you have more than one independent variable, if simple, 1x, 1y. For multiple, 1y, many x. Yeah. And in this case, both are continuous variable. Yeah. Okay. So in R, this is how we set up the the simple linear regression. LM means stand for linear model. Y tilde X. Yeah, Y is the dependent variable, X is the independent variable. So for multiple linear regression, we add other variable like one. Let's say we have more than one, x1 plus x2 and so on. Okay, that will become multiple linear regression. So that is how we predict the model using R. Yeah, LM. Okay, any questions so far?
No, Dr.
Boleh ya? Nah, okay. Okay, general model of simple linear regression is y equal to beta naught plus beta 1x plus epsilon. Okay, where beta naught is the intercept, beta 1 is the, what we call it, regression coefficient parameter or simply slope. And epsilon is the random error. Okay, now the characteristic of the random error, it has mean 0 and variance unknown. Yeah. And it is assumed to be independent. That means uncorrelated. Okay, so the estimated equation or line of best fit of the simple linear regression is given by y hat beta naught hat plus beta hat 1x. Yeah. So beta 1 is the slope, or we call it the regression coefficient. Okay. So in the hypothesis testing, we interested to test on the beta 1. Yeah. Beta naught, it is not that practical. Yeah. So beta 1, kita nak, we want to test whether there is a relationship between x and y. Is we are testing on the beta 1, or the beta 1 equal to 0 or not equal to 0. Okay. So this is more illustration on how we show between the, okay, the dots, the black dot is actually the actual value or the observed value. In the blue line is the predicted model. Yeah, actually the line is not there. Yeah, it is just an imaginary line. Yeah, when we have data, we formulate, we take this the regression model, you know, the simple linear regression, and fit into our data. Yeah, so it is actually the model, the predicted value. Okay, so the difference between the observed and the predicted value, okay, is known as the residual or error term. Yeah. Okay. So we check data assumption. Graph is used to visualize data and is particularly very useful before numerical analysis is conducted. Okay, before we do any modeling or fitting model, linear regression model to our data, first we need to look at the data assumption. What type of data that should fit in for the simple linear regression model? Okay. The first one we conduct monomality test. Okay, graphically, it is easy, either using histogram or box plot. Okay, and then we do the linearity test using scatter plot. We observe the trend and linear, whether it is linear or non-linear. Okay, so using we can either use we use plot ini salah ni bukan not box plot not this one. And then finally we check on the homoscedasticity checking for the constant variance Okay, let's try this one. Okay, so we copy this into our R. Okay, again, could you please your R notebook? Going to clean this. Okay, are you okay? Are you opening R now? No? Can you open your R? Boleh ya? First, you need to attach your cast data. Yeah, actually, this data is from the datarium. Yeah, so you should I think we have installed it last week. Datarium. Okay, attach. Or you simply then okay, then I'm going to rename my data into DT. Yeah, my cast data into DT. And then I can have a look at its head and tail. So there are two variables, speed and distance. Yeah. And there are altogether 50 data each. Okay, are you with me?
Yes, sir.
Okay, good. Okay. Then, as usual, we need to look at the data structure. It is a normal habit. Yeah. And then you can find the find the descriptive for both variable. So there are two variable, 1 and 2. Each variable have 50 sample size. Yeah. For speed, we have 15.40 for the mean, whereas for the system, 42.98, and so on. We have standard deviation, median, trim, MAD, mean, max, and so on. Yeah, and the last one is the standard error. Boleh? No? Boleh ya? Is that all right? Mohsin, is it okay, Mohsin?
Assalamualaikum, doctor.
Is it okay? Waalaikumsalam.
Doctor, due to my laptop's problem, today I am watching in mobile phone. So,
Oh, yeah. Okay, it's okay. It's okay, no problem. Okay. And then, so, yeah, that is the descriptive, descriptive statistic, or you can simply use summary, also possible. Okay. So in this case, we have renamed our cast data into DT. So in future, you can just choose here, change the data name. Okay. Okay, and then we can plot this. Yeah, we want to look at the histogram or the box plot. Okay. How do I take this? Can you see the plot, both plot, or I can zoom it? Okay. So this is the histogram for the distance and also histogram for the speed. Okay. So you can see that for the distance, for the distance, it is slightly right skewed, but not bad. Okay. And for the speed, it is almost bell shape. Yeah. So in other words, we can proceed with linear regression modeling since it is almost normally distributed. Okay. And we can look at another plot, that is the box plot. Okay. Why this not? Okay. So this is the plot. Okay. So it is right that for the distribution, it is slightly to the right. Yeah, right skewed. And this one almost symmetric or almost bell shape. Yeah. Okay. So there are two ways. Either you use histogram or box plot. And we also investigate on the linearity using scatter plot. Yeah. Okay. So looking at the scatter plot, yeah, it shows that there is a positive trend between speed and distance. As the speed increasing, so has the distance. Yeah. So that is the scatter plot, and also we can look at the correlation value. Okay. So remember the classification for the correlation. If it is close to 1, the closer the value to 1, that means there is a strong positive relationship between the variables. Yeah. The direction is positive and the strength will be positive, a strong positive relationship. That is given by the correlation value or correlation coefficient. Okay, if you want to look at the coefficient of determination, yeah, that is R squared. Okay, so we can simply square this one. Okay, so we write R2, that means R squared. Yeah, to the power of 2. And then we call R2. Okay, which is 65. So we can interpret that 65.11% of the variation in the distance can be predicted by the speed. Okay, so that is how we interpret it. Okay, any question? Okay, beside all of this analysis, so make sure you know how to describe, how to interpret. That is more important, yeah. Rather than running the codes, yeah. So you must know how to interpret it. Okay, any question?
Doctor, I have a question.
Okay.
Actually, what is the basic difference between statistical analysis and numerical analysis? Is there any difference?
Yes. Numerical mean you need to what we call like let's say if you want to estimate something, if numerical you have a mathematic and you give the value, then it will try to find the value that is closest to the one that you want to predict. But for the for the statistical, you have the model already. Okay, and then we feed in the value, it will give you the results. So it's different approach.
Okay, doctor, I got the point. Thank you.
Okay. Okay, so when we want to fit, okay, after we check our data, the suitability of our data for the model that we want to use, yeah, so we can see that our data is almost normally distributed, so we can proceed with the modeling part of fitting model to the data, yeah. Okay, so the simple linear regression tries to find try to find the best mathematical equation which can relate the two variables, independent and dependent. Graphically is known as the line of best fit. So the predicted simple linear regression model will be in the form of y hat equal to beta naught hat plus beta, or should be hat there, beta 1 hat x, yeah. So independent, okay, the interpreted regression coefficient of slope can be written as the value of dependent variable which will increase or decrease for each unit of the independent variable. So that is how we interpret the slope value. Okay. So if the coefficient is negative, so it will be interpreted as the decrease. Yeah, the variable, the dependent value of y will decrease, for each unit of independent variable if the coefficient of beta 1 is negative, yeah. Okay, so we use the same data set. Okay, this is how we model it. Okay, I name the model as linear mode. Okay. And call the name. Okay, so this is the equation. The linear equation for the data, for the class data. So that means you can write that y hat, I just writing it, equal to, I'm not going to execute that, y hat is equal to, so this one, the intercept plus, the slope is 3.932x. Yeah, so where x here is, so y is equal to this distance, and x is our speed. Okay, so that is our equation, the equation for line of best fit. Is it okay? Using LM, using this function. And the first element in the parenthesis will be y tilde x, or y has a function of x. This is a general one, LM y tilde x. Okay, so this is a general R code. And of course, you need to call your data there. What is your data? name of your data. So actually I can use DT lah, since I've renamed my data as DT. Yeah, so it should be the same. Okay, is it all right? Boleh?
Yes, doctor.
Okay, good. Okay, can you take the marketing data? Remember the marketing data that we used last week? Marketing data? Have we discussed about marketing data last week? This data? No?
Doctor, you have discussed Facebook, YouTube.
Yeah, that's right. We have this.
Yes, yes.
Okay. Can you do linear regression model? Okay. Maybe first thing first, check on the whether the data is its linearity, yeah, its normality. Can you check that on that using the steps that we have above, and also the correlation? See, can you repeat this step? Normality, linearity, and also the, yeah, especially normality and linearity, since we plan to use regression model, yeah, specifically simple linear regression model to the data. Okay, I want you to try that. Okay, maybe you choose one of these variable first. Yeah, YouTube or Facebook or newspaper or sales. Yeah, either one. Okay. Okay, since how many of us here? So we have Mohsin, Nur Sofia, and Nurafira. Could you please take one each? So sales will be our dependent variable. Okay. So Nurafira, can you take YouTube? Oh, Mohsin, you are on telephone, yeah. Maybe Safia, Nur Safia, take Facebook.
Doctor, I'm sorry. I'm outside right now.
Oh, okay.
So I'm not
Siapa
with
yang
my
kat dalam? Ha?
so I'm not with my laptop right now.
Yeah.
Okay.
Okay, Fatimah dah left since she's not feeling well. Okay. Okay. So Sofia boleh? Nur Sofia Ida you. Boleh Sofia?
Saya dekat luar, jadi saya pun tengok dekat telefon.
Oh ya ke?
Sorry doktor.
Okay. Okay. Tak apa, nanti kita apa ni. Okay, tak apa. That will be maybe your maybe I give you the apa ni for the quiz, yeah, for the quiz. Okay, so using this code, we have this. Okay, so our predicted really simple linear regression is model is y hat equal to negative 17.579 plus 3.932x. Yeah, so we can interpret the regression coefficient. Yeah, regression coefficient that the distance y will increase by 3.932 for each unit of speed. Yeah, so that is how we interpret the regression coefficient. Okay. Now we can draw the line of best fit. Yeah. So in R, we just add this function, AB line. Yeah, AB line, take the model, and then You can color it red so it is clear. Yeah, but first of all, you need to draw the scatter plot there. Yeah, this is known as scatter plot. Yeah, so you have your Y, your X, sorry, your X, your Y, and this is just naming it. Yeah, so you can highlight that. Okay, so let's say I don't want the multiple plots there. Okay, so that is clearer. Okay, so if I zoom, okay, so this is the regression model, the simple linear regression model, distance against the speed with its lines of best fit. Yeah, the red one is the line of best fit. I mean the model. Yeah, the equation just now, the simple linear regression model. Okay, which is also known as line of best fit. Okay, any question?
Doctor,
Mm.
is the calculation for the coefficient is the same if we use if you want to do the polynomial regression?
Boleh, tapi you need to polynomial maybe if it is squared, you need to square your apa ni, your variable in the model. Because when we talk about simple linear, the one dependent and then your predictors atau independent variable to x2 must be to the power of 1 if it is simple linear. But if yours is polynomial, let's say quadratic, so your independent variable may be to the power of 2, to the power of 3, and so on.
Okay.
Okay?
All right.
Okay, good. Okay, and then okay, so now we got the model. Yeah, after we got the model, yeah, so far we got the model already. We take the simple linear model and fit with the data. Okay, so the next step will be to ensure that the model that we use is significant. Yeah. So hypothesis testing for linearity. That means the linearity is really exists. Yeah, with the model. Yeah. So for linear equation or linear regression, we need to test on the slope because the slope is the factor that form the equation, isn't it? Yeah, beta naught is just the intercept, the y-intercept. But beta 1, yeah, either beta 1, 0, the beta 1, 0 means your data is flat. Yeah, it's horizontal. Yeah, but if it is not 0, yeah, it can be, let's say, 45 degrees or the negative relationship. Yeah, so that is why we must make sure, or we need to do the hypothesis testing for linearity. So yeah, we need to do the model assessment. Okay, so this is the hypothesis for testing the linearity, the existence of linearity in our data. Okay, so this is the hypothesis. And then using R code, you can get everything using the function summary. But first, you must get your model. You can fit model dulu, and then you write the summary. So it will give you the hypothesis testing results. Okay, so this is the result. Okay, before that, we take this one. Okay, so we have fitted our model in R. Okay, this is our model. So now we want to test for linearity. Okay, so simply run the function summary and it will give you this. Okay, so this is the similar similar output. Sorry, the coefficient table. Yeah, so you can see that which predictors is significant. Yeah, so we look at the p-value. Okay, so the intercept is significant, so as the speed. Yeah. So what is 1 point, how do you change this into a normal value? 1.49 E-12. What does it mean? How do you change that? Huh?
Times to the 10 to power of 12. Is
Huh?
it
To the power of
12?
12? Are you sure
Negative.
12? Yes, negative 12. It means 0.0000 until 11, then you have 1 point, isn't it? Yeah, and 149. Okay, so it's very small. So in other words, p-value is less than 0.05. Okay, rule of thumb, we choose significance level has 0.05. Yeah, so it's very small. That means it's very significant. Okay, so it is significance. Yeah, dekat normally they put a star, yeah, to show that it is significance. Yeah, and then what are the things that we look for this analysis? Okay, so first, based on the linearity test, we know that the coefficient of speed, yeah, is not 0. So that means it's significant. Yeah, when it is significant, that means there is a relationship between speed and distance. Yeah, a linear relationship. Okay, and further down, you can also see the multiple R squared, adjusted R squared. Yeah, and yeah, the p-value. Yeah, p-value. Okay, so normally we look at this p-value for linearity test. Yeah, this one, the coefficient, the significance of the coefficients. Yeah, or the independent variable. Yeah, this table. Yeah, significance of the independent variables. Yeah. Okay. So we have this. Okay, this output. So what is important is first to look at this part. Yeah, especially this part is very important. Yeah. Normally we look at the p-value first. Yeah, which is 0, 0.000, and then we look at the multiple R squared or multiple R adjusted. Yeah. Actually, since we are dealing with only simple, one variable at a time, one y, one x, so it is advisable to use this one, 0.6511. But if we are talking about multiple, this is more appropriate, adjusted R squared. Okay. Okay, so from that output, we know that the predicted simple linear regression is y hat equal to negative, yeah, the slope, the intercept plus the slope times x. And we need to test for the linearity. So you must have this statement. So you are testing beta 1 equal to 0. That means there is no significant linear relationship between speed and distance. And the alternative will be beta 1 not equal to 0, or there is significant linear relationship between speed and distance. Okay, since p-value is equal to 1 point something times 10 to the power of negative 12, so it is 0, it is less than alpha, yeah, 0.05, rule of thumb. So we reject the null hypothesis. We reject this part. Yeah, that means the slope is not 0. Yeah. So at alpha 0.05, there is significant linear relationship between speed and distance. Yeah. And then we also comment on the coefficient of determination from that output, that is R squared equal to 0.6511. Since this is a simple linear model, so we only take R squared. Yeah, but if we are dealing with multiple linear, we need to take the adjusted R squared. Okay. And also we can, how do we interpret the coefficient of determination? So we can say that 65.11% of the variation in the distance can be predicted by the speed. Yeah, in distance can be predicted by the speed. And the last one, we can also construct our confidence interval. Yeah. For the standard errors. Yeah. What is the range of our prediction? Yeah. The range of our prediction. So we can do that using this formula lah. Yeah. So kita tengok plus minus to standard error. Okay. So we have checked the data. It fit to linear model. Yeah. Now we have the linear model, and then we check. Yeah. We assess the model whether it is significant or not. Okay. And the next step will be, this is actually alternate. We look also on the residual. Yeah. Residual is very powerful. Yeah. Analysis. So residual is the difference between observed yi and the predicted, denoted by E sub I equal to yi minus y hat I. So the residual analysis can also be used to check the model assumptions of linearity, independent, normality, and equal variances. So more application if you use residual. Okay. So large values of residual may indicate possible outliers of an unusual observation. Yeah. So just take note of the large values of residual. Yeah. Okay. So how do we do residual analysis? First, step one, always to fit the regression model first, like what we did before. And then we can draw the plot between residual and the fitted plot. Yeah, to detect heteroscedasticity, a system may change in the spread of residual over a range of values. The third one is we can use QQ plot. Yeah. So we are expecting if the model fit well with the linear regression, the residual also will have a normally distributed pattern. Yeah. And if the data fall along the straight line at 45 degrees. And then the last one, this is optional. We can also check on the density plot for the residual. Yeah. So ada about three ways. Yeah. To use residual analysis. Yeah. Okay. So we can copy that. Okay, so first thing, we call the data, we model it, yeah, and then we get the residual, yeah, get the list of residual. Okay, let's say I change this to data. It is cast so that you have a general formula. Okay, model. Okay, I can take out the value for the model. What is it? So give you that one. Okay, and then we take the residual using the function resid. So what is residual? Okay, so this is the value of the residual. So there are 50. So you take the observed value minus the predicted value on the model. Yeah. So that is the residual value. And then we do the plotting. Okay, this one is the second one, the second step. Okay, so we can see that there is no, we can see the randomness, in the data. That means there is no specific trend, no specific trend. That means the data is, the residual is normally distributed, okay? And then we can also use QQ plot, okay, and fit the line to help us, that apa ni, okay? Okay, so we can see that most of the data is close to the straight line, majority, as compared to these few points here, which is stray a little bit from the straight line. So again, this one shows that our residual is normally distributed also. Okay, and the last one, okay, so again, looking at this, it is almost normally distributed. Okay, although there are a bit of outlier out there, but the majority of the data is normally or has a bell-shaped distribution. Okay, so that is how we testing our, we assess our model adequacy using residual. So there are two ways. One is testing on the linearity and so on. Secondly is using residual. Okay, any question? Yeah. So more explanation.
Okay, doctor.
Huh?
It's
Yeah,
okay, doctor.
Huh?
Okay, doctor, no question.
Okay, very good. Okay, so just more explanation on how we comment on the residual versus fitted plot. Okay, so on the Y is the residual value, and fitted mean the Y hat value. Okay, so you can see that we can see that the data is randomly scattered between these two variables. So scattered around the residual line of 0, which suggests linear relationship is reasonable. Okay. And then secondly, the residual roughly form a horizontal band around the residual line, within a certain limit. Line of 0, which suggests that the variances of the error term are equal. So from this plot also, it tells us about the variability for the residual. In this case, we want it to be equal. Equal. Okay. And then the last one is most of the residual from basic random pattern we suggest form a basic random pattern. We suggest that there are no significant outlier or no outliers. Although there are few but majority of data is within this area. Okay, for normality plot, the comments that we can make, most of the points are close to the straight line, so the residual is normally distributed. On these few points, is stray away from the, or moving away from the straight line. Only a few points. These two. But the majority of data out of only 2 out of 50 is moving away from the straight line, but 48 over 50 is close to the straight line. So so it is normally distributed. This one using what we call quantile plot. And the last one using the density plot of residuals. Okay, so from when we plot the density for the residual, the shape is almost bell shape. So on the slide is skewed to the right because of the outlier. So we can conclude that the residual is almost normally distributed. Okay, boleh. Okay, so since you are not in front of your company, so maybe I leave this exercise for you to try. I'll give you the data, food, diet data. Is it okay?
Yes, Doctor.
Okay, good. Oh, this one dah ada lah. Dah ada dia punya analisis. Okay, tak apa. Okay, maybe you can simplify that. Okay, boleh. Okay, so now we move to multiple linear regression model. Yeah, multiple linear regression model. So the estimated model, yeah, of course, if you can extend from simple to multiple, if simple, we only have one X, one Y, but multiple, we have many X, many Y, yeah? So I should have X1 there, yeah, X1, X2, and so on, yeah? X1, X2, yeah? I'll make the correction, yeah, later. So similarly, Y hat is the response variable, and X1, X2 up are the predictors, yeah? So beta node is the estimated regression constant, whereas beta 1, beta 2 are the estimated regression coefficients, yeah? So multiple here refers to more than one predictors, yeah? And linear refers to the power of predictors, which is 1, okay? That means the power of x to the power of 1, x2 to the power of 1, xk to the power of 1. That why it is linear. Like what you asked just now, if it's polynomial, maybe you have x squared, x cubed, and so on. Yeah, so it is no longer multiple linear, but non-linear model. Yeah, the way we treat is different. Okay, so at this point we only talk about linear model. That is when the power of the variable of the predictors or the power of the independent variable is to the power of 1. Okay. Boleh? Is it okay?
Yes, Doctor.
Okay,
Okay.
Doctor.
Okay, so for multiple linear regression, step 1 would be to draw a scatter plot as usual. Okay, scatter plot matrix. Yeah, graphical representation is will help us a lot. Yeah. Okay, secondly, to find and interpret the correlation coefficient and coefficient of determination. Yeah. And then we describe linear relationship involving a dependent variable with 2 or more independent variables. Then we need to do hypothesis testing for multiple linear regression. And then before we use the MLR. Okay. Okay, this is a scatter plot. Okay. We use the marketing data because it has more than one independent variable, yeah, because you want to see the effects on the sales using YouTube, Facebook, and newspaper, yeah, how the sales affected by these variables, yeah, the 3 independent variable. Okay, so you can copy that into your R. Yeah. Okay, so this is the okay. Can anybody tell me Which variable that has a strong relationship with sales? Which one? YouTube, Facebook, or newspaper? Any idea?
YouTube.
Which variable, independent variable, affect the sales mostly, or has a strong relationship with the sales? If we compare between these three,
YouTube.
hmm?
YouTube.
Sorry,
YouTube.
which one?
YouTube, Doctor.
Huh? YouTube. Yes. Why you say YouTube?
YouTube has the more relation with sales.
Why? Why?
Because the points, scatter points are very close to the linear regression lines.
Okay. What about Facebook? Can you comment on Facebook and sales? Yeah, that is a good description between sales and Facebook. How about Facebook?
There are many outliers.
Okay, many outliers, yes. Okay, what else? Yes, outlier, especially this part, yeah? The part on the left, top left, yeah? Okay, although you can see that this line, yeah, it is quite intact to one another, but there are many outliers at the top left, yeah? Okay, what about between newspaper and sales?
It is not significant.
Yes, yeah. You can see that relation is very weak, isn't it? Yeah, there is no specific trend. Yeah, like Facebook and YouTube, you can see it is apa ni, a clear positive trend, isn't it? Facebook, okay, but not that strong. Yeah, it is still positive, but not that strong. But newspaper is very weak. Yeah, very weak, and there are a lot of outlier there. Yeah, if you put a line, yeah, within the data, it's like a flat, yeah, horizontal line for the newspaper. That means the relationship between newspaper and sale is not that good, or weak, weak. Okay, good. Okay, that is how you interpret using the graph. Okay, and then we look at the correlation value. Yeah, so you just type cor. Okay, and okay, what is the function of round? What is the function of round there? Okay, so we want to calculate the value of the correlation. So what is the function of round in front of it? What did I do? Just testing the R code on you. Okay.
Change the decimal place of the value.
Sorry, it what?
Change the decimal place to 4 places.
Yes, yeah. So it changed the from how many decimal places? Yeah. So you can always manipulate this if you want 2, so it will give you 2. Yeah. So number of decimal places. It depends on your interest. Yeah. But normally rule of thumb we use 4. Yeah. Okay, so this one using graphical. So when we look at this value, this value, this is the numerical value there. The numerical value. So you can see that YouTube and sales, the correlation is 0.78. That means strong positive in a relationship. Whereas Facebook, moderate, 0.5762. And newspaper is very weak, only 0.2283 at 3, the correlation. So we look at this part. Okay, so the most significant is YouTube. The most strongest correlation coefficient is between YouTube and sales. So that one is looking at the correlation coefficient. I think it also wants us to look at the. So this is an example on how we interpret the correlation coefficient. Okay, by now I should also interpret the coefficient of determination. So if you want to find the coefficient of determination, to interpret that, we must square all of this. Square this. So maybe you dapat about maybe 50%. 50% of the data of the sales can be predicted by the YouTube and so on. By the budget allocated for YouTube. And this one, if you square it, so become very small percentage. Okay, like ini become 25%. For the coefficient of determination. By right, I should have also the coefficient of determination here. So I can tell how much variation in the sale can be predicted by the other variables. Do you get my points? For the coefficient of determination, we need to square this so that you can explain how many percent the variation in the sale, which can be predicted by YouTube, by newspaper, and also by Facebook. Okay, do you get that point? Boleh?
Sorry, doctor, what's the question?
Okay. Whenever we use core function, okay, we only got the correlation value, right?
Yes.
Okay. But to get the coefficient of determination, you need to square all of this, right? Square this, square this, square this. Boleh?
Yes.
Okay. So that value you change to percentage. Like what we have before. If I can go back. Okay. So the coefficient of determination is R squared. Okay. So you can say that,
just multiplied by 100.
Yes, multiply by 100. Squared it, multiply by 100, then you can interpret like this. Boleh?
Yes,
okay, good. Okay, so that is what I meant because I didn't show in the slide there. Okay. Now, the next step will be to, first we look at the value for the correlation coefficient. We look at the plot and then we look at the numerical value of the correlation. Okay. Using the core function for graphical, we use PAIRS function. PAIRS. Okay. PCH here is just that we want to use the black dots, the solid dot for the data. If you just leave it now without the PCH, okay, it will become open dots, not solid, black solid ni. Dot. Okay, the next step will be to fit our multiple linear regression model to the data, yeah, because now we considering the other two variable, yeah, Facebook, newspaper, and also YouTube. Okay, so become linear regression. So you can see that the same function LM, sales is the dependent variable Y, tilde, that means has a function of x1, x2, and x3. And the data is our marketing data in this case. Okay, so the output will be this. Okay, so from this analysis, we can write our multiple linear regression, the estimated. Yeah, so you just take all the coefficient. Okay, this is the intercept. This is coefficient for YouTube, Facebook, and also newspaper. So in this case, I make it X has the YouTube, Y has the Facebook, and the newspaper has the Z. Okay, by right, I should have negative there. Sorry. Okay, is it all right? Boleh?
Okay, doctor.
Okay, good. Okay, alternatively, you can also use LM sales tilde dot. Yeah, that means it will include all variable, because if 3, maybe we can try. Yeah, 3 variable, but talking about 10 variables. Yeah, if you want to form a multiple regression of 10 independent variable, so you don't waste time to type. So you just write tilde dot. This is your Y values, the dependent variable, and tilde dot. And make sure you specify the data. Yeah, so it will give you the same model. And alternatively, the second code is if you want to remove one variable or two variable, you can use that. Negative, and then let's say you want to remove newspaper. So the model that you will be modeling will be, fitting will be without newspaper. Okay. So can you understand that? This is another way, yeah. Especially if you have more than 5, more than 10, yeah, independent variables. Okay, so you can try that. Okay, so this is the model. Let's say this is model 1, just to show you different way, yeah. So this is model 1. Let's say this is model 2. Yeah, I just want to put a dot there. Okay, so the same thing. Okay, or if I want to remove certain variable. Let's say I want to remove newspaper. See, newspaper is not practical to be included, so I'm trying to remove it. Yeah. Okay, so let's say this is model 3. Okay. So we only include YouTube and also Facebook. Okay. Or even if you only want okay. Yeah. Okay, since we know that from the previous analysis that relationship between newspaper and sales is very weak. Yeah, so we can remove that using the negative in front of the variable. Okay, is it okay? Any question? Any question?
No, doctor.
Boleh ya? So you can understand ya.
Okay, inshallah.
Okay, inshallah now we look at a more detail. I mean the okay, so this one to get the model and then to get more detail on the model adequacy or we want to assess our model. Okay. So we use the same function, but now summary of the model, yeah, like what we did for the linear regression just now. Okay, now we have more. Okay, so you can see that clearly from the coefficient tables. Yeah, newspaper is not significant since its p-value, and the last one is the p-value, is greater than 0.05. So we are going to do not reject null hypothesis. Okay, that means it is significant. It is not significant. Yeah, since the correlation between newspaper and sale is very weak. Yeah, but the rest, yeah, the YouTube and also Facebook, they are significant predictors because the p-value is less than less than 0.05. Yeah. Okay, and then okay, since this is a multiple linear, so we are going to look at the R squared value. Adjusted R squared. Yeah, that means 89%, 89.56% of the variation in the sales can be predicted by YouTube, Facebook, and newspaper. So newspaper is very but most contribution is from YouTube and Facebook. Okay. And this model is significant because p-value is less than 0.05. Yeah. So this one, I comment on the coefficient of determination using the adjusted R squared, which is 0.8956. That means 89.56% of the variation in the sale can be predicted by the budget allocated for YouTube, Facebook, and newspaper. So this is a general model. So that is why we still include newspaper there. Okay. What about if we find the summary without the newspaper? How does it change our analysis? Yeah, our results. Okay. This one without the newspaper. Okay, so it doesn't change much. It is 89.62 just now. Just now. Okay, okay, we haven't done the summary yet. Okay. Model 1, sorry. So we need to look at the summary so that we can compare. Okay, 89.56. This one also 89 point. So it changed a little bit, 0.62. Yeah. So without newspaper, the coefficient of determination is higher compared to with newspaper. Okay. So actually newspaper they pull down the coefficient of determination value. Yeah. So actually we have a contribution for between YouTube and Facebook is much more as compared to if you include all. Yeah. So in statistics, we want the simplest model as possible. So if you compare between, if we include all the three variables, all the three independent variables with only two, that means two is better. Yeah, sometimes they refer to less expensive. Yeah. Although you include only a few variables, but it still give a good contribution to the model. You get my point? That is very very important understanding regarding modeling. Yeah, the simple your model is, the better. That means the less variable you include, the better. That is the concept of parsimony. Have you heard about that term, parsimony? Hello?
No, doctor, just clarify, please. What is
Parsimony. That means if you have a choice, yeah, between to include 3 variables or 2 variable, yeah, but if you look at the coefficient of variation, if the 2 variable contribute more to the coefficient of variation, that means higher, yeah, like 0.8962 compared to just now 0.8956, yeah, that means between these two models, the one with less variable is the better because it contribute more to the model. Is it okay? To the efficiency of the model. That is called parsimony concept. Is it okay?
Okay, doctor.
Okay, boleh ya. So in statistic, the less variable, the better. Yeah. Maybe I include that one also. Parsimony concept. Okay. Okay, so once we check on the coefficient of determination, yeah, then we can test the hypothesis. Yeah, is it really significant or not? Yeah. So just to confirm, yeah. So the hypothesis that there exists significant relationship between the response and predictor or explanatory variable are as follows. H null, neither of the independent variable is related to the dependent variable. That means all the coefficients are zeros. The alternative will be at least one of the independent variable is related to the dependent variable. Yeah. Or you can write the hypothesis as using the mathematical symbol. So beta 1, beta 2, and so on is the coefficient of the variable. Yeah. The alternative will be H1 not beta J not equal to 0 for at least 1, J equal to 1 up to K. Yeah. So this is the hypothesis. So when you want to justify your answer using hypothesis testing, so you must state your hypothesis and also, yes, you must state your hypothesis. Okay. And then you are going to look at your p-value. Yeah, if it is less than alpha, that means you are going to say that there is a linear relationship between the variables. Yeah, at least on one of the independent variable is related to the dependent variable. So that will be your conclusion. Okay. So to determine which one is the best will be to go through this. Yeah, looking at the R squared and also adjusted R squared. Okay, so maybe you need to list down all of that. Okay, so basically in when we conduct multiple regression, in multiple regression there also have simple regression. Yeah, so it is a subset of, yeah, a simple linear regression is a subset of multiple. So when you conduct multiple regression, you also need to look at the simple linear, yeah, within that analysis. Okay, if I can show that. Okay, now maybe we do this way, yeah. Okay. Okay, this one when we have 3 independent variable. Yeah, we include 3 independent variable. Okay, so we have model 1. Then you can summarize this one. Okay, now the rule of thumb, if we have 3 variable, we are expecting 2 to the power of 3 minus 1 possible model to be considered. Okay, so we either have, okay, the three variable that we include, we look at y versus, let's say I write x, y, z. X is for YouTube, Y is for Facebook, and Z for the marketing. Sorry, for the newspaper. Okay, so I got one model there, and then secondly is when we include two independent variable. That means I need to look at y versus xy. Okay, I also need to look at y versus xz. Okay, and I also need to look at y versus yz. Are you with me? This is my, sorry, my model is what? Y, x, oh, okay, okay. Okay, if that's okay, we change to x1, x2 lah senang. X2 and x3, yeah? If not, we will be confused, okay? Okay, do it again. Okay, x1 and x2. Okay, x1 and x3. And y versus x2 and x3. Okay. So, okay. So this one, YouTube, maybe I can define the name. X1 has I hope that I can do that. Takut tak jadilah. Okay, tak apa. So for the two variable, I would choose YouTube plus Facebook. Okay. And then, okay, I make it to 1. Okay. And then I make it to 2. So there are three possible model to 2. Yeah, which is YouTube, Facebook, YouTube dengan newspaper. Okay, and then newspaper, Facebook and newspaper. Okay, can you follow what I'm doing? Can you follow what I'm doing? So there are 7 possible model that I need to consider. Yeah, before I choose the best one. Facebook plus newspaper. Okay, YouTube plus Facebook, YouTube plus newspaper, Facebook plus newspaper. So that is for 2 variable. And then for 1 variable, okay, so this is 3, 2. So 1 variable, I have 1 each lah. 1 variables, that is y versus x1, y versus x2, and y versus x3. Okay, so I'm going to call it 3, 1. Okay. So this is just apa ni, simple model, simple regression model, 3-1, and I have 3-2. Okay, so YouTube, newspaper, Facebook, and the last one will be 3-3. Will be newspaper. Okay, can you follow me? Boleh? Can you follow me? Okay, so I'm going to run this and look at the summary. Okay, for 8956. Okay, if you include all, but if we look at include only YouTube and Facebook, and then get the summary of it. I need to get the summary of it, yeah, not only the equation but the summary of the model. So I should have summary for each one. Okay, so if you include YouTube and Facebook only, so it is become higher, yeah, without the newspaper. And also, if we include newspaper, what happened? Yeah. Okay. And similarly for this, yeah. This one, I prepare the summary first. 1, 3, 1, 1. Oh, the 3, 1. 3, 1. Okay. So 3, 2. And 3, 3. Okay, so okay, are you with me? Are you with me? Hello?
Yes, doctor.
Okay. Okay, so you need to observe. Okay, this one without the newspaper, it is increasing. Okay, and then we look at what about YouTube and newspaper? Oh, ini tak the summary pula. Aduh. Okay, 2, 2. Okay. So it is become less, isn't it? It is less, become less because the effect of newspaper. Yeah, because newspaper, the effect is weak. Yeah, so that is why when you have these two combination, it become lower than 0.8 just now. Okay, so definitely we are going to reject anything related to newspaper. We are going to reject it. Okay, and then we look at if we have only Facebook and newspaper, is it going to go lower? 1, 2, 3. Sorry. Yeah, it become lower because Facebook also less, yeah, as compared to YouTube. Yeah, so if we combine Facebook and newspaper, yeah, so the effect is lower. Yeah. Only 32.59% can be predicted from this. Yeah. The sales, only 32.59% of the sales can be predicted by Facebook and newspaper. Yeah. So the rest, the other percentage is other factors lah. Okay. Can you get my points there? Boleh?
Yes, doctor.
Okay, good. Okay, what about if we only choose only one variable. Yeah, look at the summary value. Okay, this one 0.69. So that means if you look at the YouTube alone, it is not good. Yeah, but a combination between YouTube and Facebook much better, isn't it? Because you have higher of this. Boleh?
Yes, doctor.
Okay, good. And then what about if Facebook alone? What is that? Oh, missing S. Wow, where's my S there? Okay, kalau if Facebook alone, 32 just now, 660, yeah, 32, yeah. And then if newspaper, I think I can definitely okay, it become very, only 4%, yeah, of the variation in sale can be predicted by newspaper. So it's very weak. Okay, can you get the point there?
Yes, doctor.
Okay, which one is the best model? Which combination of variable is the best? Looking at the coefficient of determination.
YouTube and Facebook.
YouTube and Facebook. Okay, very good. Okay, so that's how you conclude on the best model to choose from the multiple linear regression. Okay. Okay, so I give you that part, that code, so that you can try for the multiple linear regression later on. Okay, so this is the example. For example, okay, this one using what value? Marketing data. Oh, the same data. Maybe you use other data. And yeah, okay. Oh, I did summarize all of that. Okay, oh, this one I plot also. Plot the model. Okay, I go through the checking the assumptions and so on. Okay, we can do that. So that after this you can repeat the apa ni. So this question have identified the explanatory spelling error and response variable from the data. So sometimes I use explanatory, sometimes I use independent variable, but it means the same thing. Yes, response or dependent variable, yeah, the same thing. Okay, maybe I need to use a general one, yeah, so everybody can understand it. Independent and dependent, yeah. So find the predicted regression model that what we found just now. Test the hypothesis. Okay, we test. And then identify the significant predictor variable if there is any. So we can see that the significant one is the YouTube and the Facebook. And determine the best model. That means you need to list down like what I did just now. Okay. Then kita check on the regression assumption based on linearity. Yeah, we need to check the how the assumption of adequacy model, adequacy analysis, yeah, and so on. So linearity, normality, and homoscedasticity, that is the variance. Okay, maybe we have a look at that shortly. Okay, this is the data. I think the same data that we did just now. Okay. So if we include all the bubbles, sometimes it is called full model or saturated model. Yeah, saturated model. So normally we don't take, let's say if you have 10 variable, normally we didn't take all, yeah, because they say that it's very expensive model, yeah, or complicated. Actually the word complicated there. Okay, so like in this in this example, you can see that the effect of newspaper is very low, yeah, very weak. So rather than we include all the variables, it is more than enough to only include YouTube and Facebook. Yeah, it give a good impact to the sales. Yeah, rather than we also include newspaper. So yeah, if the head of the company, if they want to invest on or if they want to allocate budget for the advertisement, they better use YouTube and Facebook rather than newspaper. Okay, do you get my point there?
Yes, doctor. I got the
Okay,
point.
good. Okay, I think we have gone through that all. We look at how do we assess the adequacy of our model, this part. Yeah, how do you check the normality and so on. Okay, hopefully we have that package. I'm not sure. Okay. Okay, we have okay, so we can change it to color red. Color equal to red, so that we can see it better. And if you want a better point, rather than open circle, maybe you use PCH equal to 19 just now that we have. Okay. Oops. Oh, okay. Wait, Oh, dia jadi merah ke situ, ya. Okay, it's okay. Scatter smooth. Oh, okay, because we smooth the plot. Okay. Okay, so you can see that the one with a okay, yeah, scatter. Yeah, for scatter, we want it to be along the close to the straight line. Yeah, close to the straight line, and it should be 45 degrees is very good. Yeah, correlation. Okay, so if we look at the Facebook, so it's slightly lower. And for newspaper, memang outline almost horizontal. Okay, so that is on the linearity. Yeah, so if you want it to be a linear relationship, it must be for at least 45 degrees. Yeah, at most 45 degrees. Flatter than that will be that means less linear. And then we check on the normality. Okay, so it include the line. Yeah. Okay, so that means if I can zoom this. Oops, where is it? I want to zoom this one. Okay, so you can see that the line, yeah, most of the data is close, except few outliers, but you can see that majority of the data is close to the straight line. So it is normally distributed for the YouTube. Okay, what about model 2? Okay, it is not as good as the YouTube, yeah, because many points, yeah, as compared to YouTube just now, most of the point. Now, many points are considered outlier there, but we can say that it's almost symmetric also. Okay. Or almost normally distributed. And model 3, when we only have sales, okay. When we only have newspaper. Okay, so yeah, again, many points are close to the straight line. Yeah, the data looks normally distributed, isn't it? Yeah, but it is not funny. Yeah, And then we want to also look on the variance. Is the variance constant? Okay. So we want to see whether it is constant. Okay. Okay, it's close to the, but this one is it's like that. It's not really purely random, isn't it? Yeah. Not purely random, yeah. Because you can see that the residual is like expanding. Yeah. Expanding. And then what model 2? Okay. So model 2, sorry. This is Facebook. Yeah, Facebook also. Yeah, it's like that. The residual, because there are many outliers there. Yeah, it's expanding. So nampak dia expand. Yeah. Yeah. Nampak ada. Yeah. The band is expanding. Yeah, not along the horizontal. Along the zeros. And the last one, model 3. That means the newspaper. Just now YouTube. Yeah. Facebook, and the last one is newspaper. Yeah, okay. So this one, okay. So similar. So variance dia not apa ni, constant also, ya. Okay, dia macam expanding, ya. Yeah. Okay. So maybe it doesn't specify that constant variance, yeah. Homoscedasticity, yeah. Homoscedasticity, yeah. So it doesn't satisfy that. Okay. But at least they satisfy linearity and also normality. Yeah. It doesn't satisfy the 3 requirements. Yeah, all 3 requirements. So only, I guess, the linearity and also the normality. Okay, any question? I think since you are not in front of your laptop, it's very difficult to do the activity. Yeah. So who is just coming in? Tan Wei Feng. Yeah.
Doctor,
Yeah.
no question, but I need a suggestion from you. Since in my thesis, I have to model machine learning. I have to develop machine learning modeling. So, is it possible to develop machine learning modeling in R language or R Studio, or it will be better for Python?
Okay, it depends. Which language are you familiar with?
Both of these are new to me. So,
Okay,
so
many people
okay.
choose Python. They said that, like my student. Yeah, but for me, I cannot check the Python code because I'm not using Python. Yeah, but I guess now many people use Python because many especially for machine learning. Yeah. However, if you want to use R also have developed machine learning. Develop code for machine learning also. So actually, and furthermore, actually, model in machine learning is actually statistical model. Yeah. If you look at what type of machine learning model you plan to use, Mohsin, can you give me an example? Clustering.
After completing my laboratory work, when I got numerous data, then I have to prepare modeling for future prediction.
Okay. Now, based on your literature, LR, what type of model do they use? The machine learning model. Because in machine learning, there are 2 types. Actually, yes, 3 types of machine learning model. There are the supervised learning, unsupervised, and also reinforcement learning. So under supervised, you have classification, regression also. And then for unsupervised, you have clustering. So under regression, you have linear aggregation, you have neural network, support SVR, decision tree, yeah, and so on. Yeah. So those are all actually the statistical model, yes, statistical model to start with. But yeah, so you can decide which program you want, programming language you want to use. Yeah, maybe Python has more example on the if you Google, there's a lot of Python codes, yeah, related to the model that you want to use. Yeah, however, yes, R also have developed a lot of machine learning model also using R. Okay, and you can easily find. And actually now, R and Python are now communicating. They can communicate with each other now. Yeah. So it depends on your level of programming, your level of your programming skill lah. Okay. But
Okay.
I haven't done. Okay, boleh? Oh, is it okay?
Okay, doctor.
So how are you going to learn Python? Are you going to take a course or what?
Sorry, doctor.
How are you going to learn Python if you said that you want, let's say you want to use Python?
Actually, I did not start. Just
Oh, you haven't started. Okay, it's okay. So yeah, you can slowly maybe explore based on based on your LR, yeah, what model, and then maybe you can search within R packages. Yeah, what are the function they use for, yes, to analyze using that particular model. That is my advice lah. If not, you have to learn another language, yeah. That is Python. So that is why I ask you, how are you going to learn Python? Are you going to learn by yourself? But there's a lot of YouTube and so on to learn Python. But yeah, learning programming language sometimes, if you don't have any basic, yeah, so you need to struggle between your study and also learning new. But it is a challenge, yeah. For me, I like that kind of challenge. Yeah, even during my PhD, I use R, although during my master I use S plus, yeah. And even my at that time my supervisor, he used MATLAB. So I'm struggling on my own, yeah. And luckily I have R community, so I can ask question in that platform. Okay, that is how I learn. But basically, my supervisor cannot help me on the programming part because he's more on the VBA and MATLAB. Okay, but it's nice lah. Yeah, looking back, you just feel surprised. Oh, just wonder how I can do at that time. Yeah, but it's very nice experience. Yeah. Okay.
okay, doctor.
So I think I stop here. Okay, I let you to explore more on R. Yeah. Yeah, I hope that you can use this knowledge and these tools, yeah, to apply in your study. Yeah. So you have 2 more weeks to go with me. After that, Dr. Norianti will take over. Okay. So maybe if you refer to the syllabus, it is a bit different. Okay. Because I try to rearrange that. Yeah. Actually, whenever we do this syllabus, yeah, this is the first time we run this syllabus, so we think that there's a lot of changes or improvement that we can make. So this is how I arrange it, yeah, to make sure you understand, yeah, the link between one knowledge to the other knowledge, yeah. So I hope that you can learn something from this lah. Okay, so today we learn about simple and multiple. Yeah, of course I will correct. Give more information on the under notes. Yeah, of the multiple linear. Because I lost everything, that the one that I prepared a few days. Since last week I prepared for this class. Yeah, so yeah. And they said that I will get back either get a new one or get repaired my laptop get repaired within a month. So can you imagine? I'm using the old laptop that I have. Luckily, it's still working. But of course, yeah. Okay. So any question before we end this session?
Doctor, I have a small question.
Okay. Good, Mohsin.
What is the assessment system actually in this subject? Is there any final exam or quiz or assignment, etc.?
Is it? I think you will have assignment. Let me check our program plan. Have you checked in Kalam? I think I should give you one lab report exercise. Okay. Two lab report exercise should give you, which cover 5% ish. Okay, I'll try my best to give you this week. Yeah, one. Yeah, yeah. And then you will have a written test on week 6, yeah, which will cover I'm not sure yet. Yeah, we should cover 1.5 hour. Yeah. Yeah, which will cover maybe all the chapters that we discuss. Okay. I will discuss on the other model, binary, yeah, and diagnostic checking, multicollinearity, leverage and influence variable, and so on. Yeah, so I haven't done that. Okay, and we haven't touched on the chapter 2 yet. Okay, selecting our transformation and so on. Yeah. Okay. So there will be a lab report. There will be written test, 15%. And yeah, you will have a group assignment. But I guess not difficult. Yeah. So altogether for lab report, one assignment, group assignment, one written test, one lab test. Quite a lot. 2, 4, 5. You will also have final exam. I don't think final exam. You will have
Doctor, assignment will be in group, right?
yeah, assignment will be in a group. Yeah, you can start forming an assignment, finding data and so on. Okay, I think Dr. Narayanti will brief you about the assignment.
And one lab test.
Yes, one lab test, one written test, one group assignment, and 4 lab report. Okay, all together. And then I guess you have final exam. There shouldn't be a final exam. I'll talk to Dr. Yanti to confirm about that. Okay, I'll keep you informed. Hopefully next week. How are we going to I'll check again. You will have a Okay, I will update you next week. Is it all right, Musil?
Okay, doctor.
Okay, good. Okay, I think we end here. So all the best to all of you. Yeah, hopefully you can you learn something and you can use the this tool, yeah, to apply in your study. Yeah. So all the best. If you have any question regarding R, yeah, or any materials that we learn, you can simply message me. Okay. So those who are your convocation day, yeah. So good. Congratulations. Okay. Okay. Bye. Assalamualaikum. And yeah, very good morning.
Thank you, Doctor.
Okay.